Welcome to JF Green Energy Concept channel. In today's video, I want to take us through the configuration of pulse motor system using the BLDC motor concept. In this case, we are using a Hall effects switch instead of the normal magnetic switch. Now in this case, instead of the reed switch, we are trying to simplify this concept and also to carry our new followers along on the wiring of this system. Here is the simplified diagram of this motor circuit. Here we have a Hall effects switch, which is 3144 is the number. Then the first leg of this transistor-like switch is the positive, which is this from the diagram. The center is the negative, while the third leg happens to be the signal, which is what you can see here: positive, negative, and the signal. Then, since we are making use of this Hall effect, the output signal is a negative voltage. Since it is a negative voltage, we are making use of a P-channel Mosfet. And that P-channel Mosfet we are using here is IRF P9540. This is the configuration goes like this. The first leg is the gate, drain, and the source. So going to the diagram, we have the battery as the source. Connecting the positive through the battery, we have 1K resistor. Then the negative goes straight to the negative of the battery. Then the signal now is connected to the 1K resistor before the Mosfet, before the gate of the Mosfet, and you have another resistor 100K connected between the gate and its source. Then from there you have your positive running from the battery to the source of the Mosfet. So down from the gate, from the drain down to the inductor, which will now propel the motor. Then the negative is connected directly. From this negative, you can now make the output of your back EMF, where you harness the back EMF. These two terminals should be connected to a recharging battery, so that when the motor is on, you can harness the back EMF through this. Remember, the back EMF, the positive output of this back EMF will be rectified to charge the battery, and it will now be transformed into a positive, while the positive here goes to the negative of the recharging battery. That's the configuration. Now going to the main circuit, we have something like this. This is the Mosfet. This is your 100K resistor. As you can see here, this is the 1K connecting the signal of the Hall effect to this. Then instead, we added an indicator light that will show you when the system is on and when it is off. So the indicator is connected through the drain of the Mosfet, then down to the gate, the drain and the gate. So from here here, you will now have the connection. Since here is the negative signal coming, then this is the positive output from the MOSFET. Then we have something like this. So this is actually how this thing is connected. You can attach your 1K resistor there. So this is actually the configuration, so we can test and know when this transistor is switched off and how to connect it. So this is the whole effect. Now you have your magnet, the north and the south pole. So once it is connected, you can see it is on because of the presence of the particular pole. Then when you turn the magnet, it is off. So this system will switch the transistor on using a particular phase of the magnet. The other phase will not switch it on. That means when you have the flywheel connected, attached with your magnet, both the north and south poles, it will be only when the system will be on only when your north pole or south is facing this Hall effect. That is why this system is different from the reed switch, which switches on whenever magnet approaches the switch. But in this case, this one is selective. It can only be on when a particular magnet is facing this Hall effect. So this is the first tutorial on this connection. Next will be how to apply this to your pulse motor. I believe this is a bit simplified for the beginners. We know that the next one will now take you through the connection and how it is attached to the pulse motor. Thank you from JF Green Energy Concept. See you next time.